Thank you for being here. I'm Henry Carter. I'm the project manager for AS Engineering, and today we're here to discuss our progress on the County Road 38 project in Goshen. To my right, I have Carly Sheen, our transportation engineer, Francesco Messina, our environmental engineer, and Darius Lane, our structural engineer. Our goals for this project are to reconstruct a section of County Road 38 and the intersection with County Road 21. With this, we will be constructing a visitor center and adjacent parking lot, and we are developing a wastewater treatment system and stormwater management system to go along with this reconstruction. Here's Carly Sheen to talk about transportation.
Thank you, Henry. As Henry stated, my name is Carly Sheen. I'm the transportation engineer for AS Engineering, and I'll be going over the transportation portion of this project. For the scope of the project, one of our main goals is to improve safety for all road users, including pedestrians, cyclists, and drivers, through the implementation of the proper infrastructure for the resources that we have. Another goal is to upgrade the level of service and stimulate economic development through the movement of goods and workers through this corridor. In this visual, you can see that some of my main goals are to analyze and design a new intersection for County Road 38 and County Road 21, design a new parking lot for the visitor center that will be constructed, realign County Road 38 with a 3-lane section, and include a multi-use path along the length of County Road 38. We also will have a path underpass located on the east side of the project that will reconnect, that will go underneath County Road 38 and tie into an existing path on the north side of the project. For gathering data, since this project is in Elkhart County, a lot of the data was provided by Elkhart County since we're under their jurisdiction. So the traffic counts and the crash data were both provided by them, and we're designing to the design speed of 45 miles per hour per the scope provided. For determining the design criteria, I designed them to Elkhart County street standards, a policy on geometric design of highways and streets, also known as the AASHTO Green Book. I designed to the Indiana Design Manual 53-2, and since this project is funded by Elkhart County, we're designing to their standards, which, unless otherwise stated, is the AASHTO Green Book. So most of the stuff that I was grabbing from was the AASHTO Green Book. For analyzing the data, I conducted a traffic impact study due to the new visitor center that will be constructed, and I used the ITE trip generation manual to grab those numbers using land use code 495. Because of that, I was also able to use the traffic impact study to see what the future volumes will be on the roadway and figure out which alternative will be best, thinking about the visitor center that will be there. Per the traffic counts that Elkhart County provided, I was also able to evaluate the existing level of service on the intersection, and the intersection as a whole has a level of service of C, which is good to see that it needs to be redesigned to upgrade that level of service. Along with analyzing the data, I also designed a parking lot. Using the ITE trip generation manual again, I deemed that, and using the fit curve equation, it was recommended 101 stalls, but I rounded up to 122 to be conservative, and it fit better with the allotted area. I opted for stall sizes of 10 feet by 20 feet for bigger parking facilities, and I also, for ADA requirements, it was recommended 5 stalls, and I rounded up to 6 accessible stalls, just for an even number. I also went with the same stall sizes, and they all have access aisles. For my alternatives, I opted for 3 different intersection alternatives. The first one being a typical intersection with channelized right turn lanes, the second one being a signalized intersection with channelized right turn lanes, and the third being a roundabout with 2 circulatory lanes. For my alignment alternatives, the main goal for the alignment is to reposition the road to make room for 3 lanes and add that multi-use path along the stretch of County Road 38, extending to County Road 21 going north on the east side of the roadway. For the path underpass, the path will have to go under County Road 38 and tie into an existing path on the north side of the roadway, and so I'll have to design a new profile to accommodate for that path and make sure that it aligns with the 50-year flood level. For this alignment, it fits pretty closely to the existing roadway. For my second alternative, I dropped the road down a little bit to make more room for the residential homes on the north side of the road and to have it tie better into the existing path for like a smoother transition. For my next steps, I have to evaluate and select my best alternative, and I'll do that by comparing all my alternatives in Vistra and decide which one is the best given my options. I also need to finish more detailed design work and model my chosen intersection in Vism to have a 3D view for my next presentation, and I need to conduct a cost analysis. I'll now be passing it on to our structural engineer, Darius Lane.
Good morning, my name is Darius Lane. I'm the structural engineer for AS Engineering. Just a few of my tasks for this fall. I had to develop the scope and design criteria for the visitor center. I had to develop 3 alternatives, I had to analyze and evaluate the alternatives, and then I will have to select the best alternative. Getting into the scope, I have to build a 40,000 square foot visitor center that is 2 stories with an additional 1,200 feet that is covered and attached to the building. My overall progress, I have developed 3 design building alternatives, and I'll get into them as one of them is a steel hexagon alternative, and 2 of them are L-shaped, one being concrete, and the other one being a combination of masonry and timber. I have a rough floor plan design alternatives, but out of scope is actually me having a detailed one, but I just needed an overall rough plan just for my column spacings and overall occupancy flows. And I have a design possible dead loads and live loads. I completed that for the roof and the floor. And I have a soil analysis of the site plan. Getting to the site plan here, pictured is the County Road 38 and County Road 21 intersection. I have a clay soil analysis and identification, and here I used the L-shaped building just to kind of give a quick idea of where I wanted to place it and the projected parking lot. For the first alternative, it's a steel hexagon shape, as it's just kind of a basic shape. It's a steel structure, has a lot of energy efficiency and flexible use, has less heat loss, which is good, especially for this area as it does have harsh winters, and I kind of predicted to have a pitched roof, but have not really gotten into the details of that, but it's kind of what I'm looking for. And these are the occupancy loads and the floors I'm looking to use for them. Getting to my L shape for both the concrete and masonry timber combination. For a concrete overview, these are just basic physical properties I've been looking at as far as how to get into them, but nothing based on the loads and stuff and column spacing yet. But just for the concrete overview, it is a little bit more fire resistant, high strength durability, and low maintenance over time, so that's kind of good to look at. And then for masonry and timber overview combination, it is more resistance against rotting over time, and it's fast construction and schedule friendly, so based on our time frame and how it's working, if we need to kind of speed it up or get it done pretty quick, it'd be nice to do that with this type of combination, and it's increased functionality and overall energy efficiency. Getting into my next steps, I would choose the best alternative based off cost efficiency, strength, durability, and overall functionality of the buildings and alternatives. I would have to come up with a cost estimate for all of them and get into more details of the masonry and timber design elements to see if that is the route I want to continue down or kind of eliminate the alternative overall. And I will determine the column spacings for that, depending on if I need to change what type of occupancy loads I have kind of already determined or stick with them. And then overall come up with a site layout construction, which would take place later on, either by the end of the semester or beginning of the next one. And I'll now pass it on to our environmental engineer.
Thank you, Darius. I am Jessica Messina, the environmental engineer for AS Engineering. My scope for this semester was to make a wastewater treatment plant that accommodates future work, future use, as well as expansion. Within this treatment plant, there must be primary, secondary, as well as tertiary treatment and disinfection. This treatment system must have a disposal outfall, as well as 1 million gallons per day average daily flow rate. With this, the system must use latest treatment technologies, as well as comply with all local, state, and federal regulations. My progress for this semester has been making 3 alternative schematics. Within these schematics, I have found 3 flow rates to be useful using figure 18-1 in the wastewater engineering book. These flow rates are 1 million gallons per day average flow, 2.9 million gallons per day max flow, as well as a 4.5 million gallons per day peak hour flow. Using these flows, I've made some preliminary sizing calculations for my alternatives. My first alternative is a full-scale activated sludge wastewater treatment plant. This begins with the pre-treatment, which is a bar rack building, which contains 2 bar rack channels, a mechanical screen, as well as a fine screen. Although 1 bar rack channel can handle the full flow of the plant, the 2 must be needed for redundancy as well as making it easier for maintenance. This then continues to the start of the pre-treatment, or the primary treatment, which are the aerated get tanks. These have a blower that blows air into the tank that separates the water from the fine particles such as grit and sand. This then goes to the end of the primary, which is the primary clarifiers, which have the oil floatables float up to the top, which are skimmed using an arm skimmer, as well as the total suspended solids settled to the bottom. This goes to the start of the secondary treatment, which are the aeration tanks, which also have blowers going into them, which feed the microorganisms that eat the organics as they eat the dissolved air. Going to the end of the secondary treatment are the secondary clarifiers. These are different from the primary clarifiers as they use all 4 types of sedimentation, otherwise known as zone settling. The particles then fall to the bottom of the tank and compress, making an activated sludge. This sludge is then pumped using RAS pumping back into the aeration tanks to increase efficiency. Finally, we move on to the tertiary treatment, which I've identified as either a disc or a drum filter that will filter out the rest of the suspended solids left in the water. Water will then continue into 2 UV channels, which use UV lights to disable viruses and bacteria. Like the bar racks, there are 2 channels, but only one can be used for the system, just for redundancy and maintenance there are 2. Finally, there's an outfall that disposes the water back into the river. Alternative 2 is very similar to alternative 1, though there is a membrane filter instead of the secondary clarifier and tertiary. This membrane filter has a rectangular basin, which is filled with water, and has 6 in-series membrane filters. The water goes through the membrane filters and traps any suspended solids in the water. My third alternative, I would have an on-site mound system, which would be located west of the visitor center. This would include a pump, which pumps it into a septic tank. Before the septic tank, there would be a fine screen to trap any of the bigger solids. Within the septic tank, we would have the total suspended solids settle to the bottom. This would then continue onto the dosing tank, which would have a dosage of chlorine before going into the mountain for the water to settle into the soil. For my next steps, I will make a design criteria matrix, which compare the sizing, efficiency, odor, aesthetics, as well as cost of all alternatives. Using this, along with a weighted factor for each one, I will determine which alternative is the best. From this, I'll make alternative specific calculations, as well as making sure to comply with all local, state, and federal regulations. With that, I'll pass on to Henry Carter, who's our water resource engineer.
Thank you, Francesco. As you said, I'm Henry Carter. I'm our team's water resources engineer. For the scope of water resources on this project, I am tasked with designing a stormwater management system that will manage the runoff from all pervious and impervious surfaces throughout the project area. This water will then be introduced into the Elkhart River watershed, and before I do that, I'll need to reduce the stormwater nitrogen loads by 50% site-wide. Currently, I have delineated watersheds as seen here. This is the roadway watershed. The blue is the pervious area, and the pink is all impervious area. This is across the river. The green is impervious, and the orange is pervious area. And the yellow is the building watershed that accommodates for pervious and impervious area in this map. I have also collected soil data for these areas, and I have calculated the flood control and water quality volumes at approximately 350,000 cubic feet and 60,000 cubic feet, respectively. And I have also designed some alternatives, which we'll discuss momentarily. A flood control volume is basically a large amount of water that comes from larger rainstorms you don't see every day, such as a 100-year storm. The goal of treating a flood control volume is to basically reduce flooding in the area and get it out of the system into the river as fast as possible. For a water quality volume, that comes from your typical design storm that you'll see every day, and that is the water that will be treated for nitrogen reduction. In my first alternative here, the main component is this infiltration basin that sits within a detention basin in the center. The infiltration basin will be collecting water quality volume from the building area, and that will flow into the infiltration basin, which will then infiltrate, treating the nitrogen and removing this volume from the site. The red detention basin here will be collecting flood control volumes from the building area and the then flow down, bypassing treatment, and go into the river since this is a flood control volume. For water quality volume of the roadway, starting on the west side here, will be a roadside ditch that takes it towards County Road 21. We'll go under the road into culvert, entering bioswales, which will then go into treatment and then into the river. The reason there's bioswales on the east side of this roadway watershed is because it will slow the speed of the water flow and it will do basic pre-treatment such as removing larger sediments from the water. So that, therefore, this will not clog the actual treatment right there. On the east side of the river, right here in pink arrows, is a storm sewer system. This storm sewer system will be released into a grassy filter strip area and then riprap before going into the river. The reason for this is to do basic pre-treatment and then prevent erosion while entering the river. There is no nitrogen treatment on this side due to extremely low volumes of water relative to this side of the river. For alternative 2, the main difference is a detention basin right there near the building area that goes into treatment and then into or back into the roadway system. The detention basin will collect all water quality and flood control volumes from the building, and any flood control volume will bypass treatment and go into the roadside ditch system to go into the river, and the water quality volume will be treated before being released back into the roadside ditch system. And when this water is treated and then put back in the roadside ditch system, this will dilute the nitrogen loads in the water that is already here from the roadway, which will require less extensive treatment right there before entering the water, or before entering the river. And then on the west side, the only difference here is the flood control volume will just go along through the culverts and then into the river and will not be redirected into this basin such as an alternative 1. Alternative 3 here is very similar to alternative 2, with the only difference being the infiltration basin, which will go into a detention basin and then back into the infiltration basin. The purpose of this is to be able to treat all water quality volume and the full flood control volume here. So the idea here is anytime there's a water quality volume going into the infiltration basin, it'll just act as a normal infiltration basin, infiltrate and be treated. Any flood control volume will overflow through a weir into the detention basin and sit there and then flow back into the infiltration basin as the infiltration is occurring in the infiltration basin. The main concern with this alternative, however, is not infiltrating fast enough. So to solve this concern, the infiltration basin will be designed to have a larger geographical footprint, so a larger surface area with deeper soil layers with more porous and larger granulates of soil, which will allow for more water or greater water infiltration rate. Finally, the next steps are to compare alternatives and to decide on the best one, to identify specific treatment methods. By that I mean identifying specifically which type of soils are used, how deep the layers need to be, plants or other chemical treatments that might go into any of the treatment components of my alternatives. And then continuing in-depth calculations for the entire system. Thank you. Do we have any questions at this time?
Yeah, question. Could you go to your first slide, I think it was?
First slide or first alternative?
First slide. Yeah, what's... yeah, that one, I guess. That's not the first one, but... so what's the difference between the blue and the green? I know you said it, but I...
the only difference between the blue and the green here is they're two different watersheds, so the design point's in the middle. That's just for calculation purposes using QGIS.
Okay, thanks. So could you go to your first alternative?
Yep.
So the infiltration basin is basically like the middle bottom part of the detention basin?
Yes.
Okay. Do you know what the soils are there, like as far as the infiltration rates that will be possible?
I don't know of specific soil composition, but it seems like sandy loam is the ideal soil here because it's kind of the the tangent point to having increased infiltration rates, but also increased nitrogen rates. So right now, this is, that's what I'm working with right now, but depending on the soil layer and also a mulch layer can also help on top of that.
So increased infiltration, but not, what would you say about nitrogen?
It will increase, or that is the greatest combination of efficient infiltration and efficient nitrogen removal.
Okay.
Is sandy loam.
So how's it get the nitrogen removal?
So the sandy loam, what that does, that doesn't remove the nitrogen. It helps the plants and macroorganisms. There's bugs and stuff that like the plants that grow well in that type of soil. So the soil itself is not actually removing the nitrogen. It just sustains vegetation better in a wet environment better than other soils.
Okay. You have to be careful because vegetation dies eventually, like annually, and then decomposes and releases nitrogen. So in the long run, it might not be doing much. So can you go to alternative 2?
Okay.
So I guess just one comment, I would probably switch the order of the treatment in the detention basin.
Okay.
The sooner you treat it, when you put it in a detention basin, it's all accumulated, it's just more difficult to treat.
My idea there was to be able to control the amount of water going into treatment as to not overwhelm it, I did be able to treat it more efficiently.
Yeah. You can do that with just like an overflow mechanism that fills up and then spills into the detention basin.
I'll look into that.
Okay, and then, so that flood control volume on the road,
Mhm.
that goes right into the river with no treatment? Is that what you said for this alternative?
So yes, in the case of there being lots of volume, in the case of flood control volume, this will go over here and some of it will be treated, yes, but in the event that there's that much volume, we're just trying to get it out of the system as to not encroach on the residential areas. So this will likely bypass treatment in the form of going over the top of it. So some of it will be caught.
Don't the regulations say that you have some maximum allowable release rate, and wouldn't that exceed the maximum allowable release rate?
That's a good question.
Okay, yeah, you should look into that. So, and then alternative 3. Sorry. Sorry. So is there pre-treatment for the infiltration basin, or will there be?
The pre-treatment will be through here. I'll go back to this real quick. In this yellow area, that is not all building and parking lot. The building and parking lot is up here. So going down through that grassy area will be the pre-treatment.
Okay, so that's purple on alternative 3 is not the building?
That is the building area. I'm
Oh.
treating that as the building area watershed, and for
So that's not
this wrong one.
okay.
Yeah, for my pervious and impervious area, I'm treating that as a percentage here. So because I don't, so far in the design, I don't have the exact footprint of all the pervious areas.
Okay. Thanks, I'm done.
Professor Reich.
All right, so this could be for almost all of you in some ways. So I'm interested in knowing kind of what does the county or the city own as far as land, and then what elements of what you're proposing might require building or putting things on land that isn't owned. So like Carly, like your drop-down roadway, the building itself, some of the basins or your treatment plant. So it kind of covers everyone.
Yeah, I know for like the building and the parking lot, we tried to pick it in an area where there was nothing, like it was just an empty field. I'm not sure who necessarily owns it. It might be someone, but, and then for the wastewater treatment plant, I believe it's on like a farm.
Yeah, I put it there to begin with because I can see the contours there and I want to see how it will flow gravity-wise, but the location is not final. I could always move it south into the field.
Yeah, and then if I went with the alternative that dropped the road down a little bit, it would be fine if he built it on the farm, because then my roadway would kind of go into the farm area anyways, if that makes sense.
And then, any concerns with your elements?
Yeah, because this is kind of what we all discussed when we even came down to picking a location, but we wanted to eventually still close to the intersection. So we had to look into obviously ownership. And that was actually something we discussed that we would have to probably purchase some land as it looks like they're farming there. So we just kind of, I always feel most comfortable with this location just due to the fact that there is already kind of another attraction there. So I feel like it would just help with the overall quality of life. And so keeping more things kind of on the central place of where there already is something and not trying to spread everything out too much.
And then, with that, from my side of things, I have relatively the lowest footprint out of all of them. So I've designed, the building area here, I included this all as one watershed. So, if we have to purchase this land, we can do it all at once. And then for my watershed designs, I'm trying to keep all the components of my system within 15 to 20 feet of the roadway. So that way, if we do have to purchase extra right of way while constructing that, we can just go ahead and purchase a little bit additional all at once. So I'll keep it confined to that.
All right, thank you.
Mr. Schickel?
Carter, alternative number 2, can you show that? That realigns the road. The message I heard from you was to move it away from the residential area on the north was one of the reasons.
Yeah.
Why then would the multi-use path be on the south side of that instead of the north side, where it would be more accessible to those?
That might be a better question.
Yeah, it kind of had to do a little bit with our water resources ideas, and then the fact that we were going to have to go under the road anyways, per like the scope provided. I figured that I would keep it on the south side of the roadway, since we're tying into the existing path on the north side, but we have to go under and create a path underpass. But I think in general, with the multi-use path, it'll be a better option than what they already have, because the existing crossing for the roadway, well, there's nothing on the intersection, and then it's right here, so they have to cross 45 miles per hour of traffic going by. But it's always something I could look into, but I just figured I'd keep it kind of in the same way, since we have to have the path underpass, and then with Henry's ideas for water resources.
I can say I requested that the path was on the south side of the roadway because the watershed flows this direction, and our guess, my goal is to put the ditch or bioswales between the path and the roadway. So if it's on the north side of the road, then I have to figure out how to get the water across that raised path area. So it kind of makes my design easier.
Well, I appreciate the coordination. The path underpass, who's designing that?
I have to design like the profile and elevation for it, but it's under my understanding that I don't have to do anything structure-wise with it. I know that like some of the options are either to lengthen the bridge to make sure that it's wide enough, or to add a structure under the westbound approach per the scope that we were provided.
I'm sure that Rice and Schickel Incorporated would be happy to design that for you.
Thank you very much. So,
I have a question for Francesco. When you were laying out your treatment train, I noticed you used ultraviolet disinfection. I know the standard is often chlorine treatment because of its cost here in the United States. What made you choose UV treatment?
I chose UV treatment because the scope asks for the waste treatment technologies, as well as I have some concerns of the chlorine treatment with the chlorine disinfection byproducts, which can be trihalomethanes as well as haloacidic acids, which can be possibly carcinogenic and there's non-carcinogenic effects to humans. Incorporating also the cost. Right now, according to the EPA, there's been a 20 to 30% increase of cost in sodium hypochlorite, and that is the main chemical used for the chlorine. So I just went with UV as is also increasing cost for chlorine.
Thank you.
So I got just one more question, because it'll bug me all day. So, on the drop-down road,
yeah.
are you proposing, so you have the drop-down section, are you keeping like the upper section still? I mean, is it kind of like two parallel roadways? Or would it all just be the lower roadway?
Like this section am I keeping, or?
Like going past the residential, like that upper part, so where the driveways are?
Right here,
Yeah.
like when I extend, right? I guess you're saying?
Yeah, so are you keeping that part and then just kind of routing the main traffic?
Yeah, so it probably wouldn't be this like extreme of a drop, but since I have to add 3 lanes and I'm not exactly sure what the profile is gonna look like for that, I just wanted to make sure that I had an alternative that kind of took the homes into effect, because I would rather drop it down this way where there's a field and less homes rather than raise it up where there's a lot of homes over there. So I would connect, or I would drop down the driveways and reconnect them to the road and make sure everything functioned appropriately. But this alternative is kind of aiming to make space for the widening of the roadway and the multi-use path as well.
I would say, maybe, look at the options if you can, because I'm not sure how easy it is to drop down someone's driveway, because that means that they're going over someone else's land and things like that, perhaps. Or it could be, I mean, it could be worked out legally, but there's nothing to say that you couldn't have like some road still providing some local access, right?
Like an access
Rather than
road.
having like a main road.
That's a good point, yeah. Something to think about for sure. No.
I have a question about the transportation.
Yeah.
Is there any concern with the queue that builds up at that intersection, building up past the driveway for your parking lot?
I don't have too much of a concern for it. I know I've thought about trying to make the driveway for the parking lot as far down as I can. The main motion of traffic is through this movement right here, so I don't think there should be too much of an issue. There's not also a ton of increased traffic being generated by the visitor center, so I don't foresee it being an issue, but I will have the necessary turn lane lights and have the approach for the parking lot be the adequate distance away. Any other questions?
Thank you.
Okay, thanks.